let's imagine that we are looking at a fixed length of space. Maybe we have a medium like this chain that has just a fixed length. And let's look at the standing wave where we've got 2 points, one end and the other, where it's not moving. Now, points where the medium is not moving at all, we call those nodes. So my left and right hand are nodes of this wave. The point in the middle where it's oscillating the most is called an antinode. So for this particular standing wave, we've got 2 nodes, 1 antinode. So what do we have for this wave that's going up and down like this? And we're going to assume that the length of our chain, the length of the medium, is some value L. So the wavelength is 2 times L. So remember, to get a wavelength for the wave, we have to have one maximum, one high point, and then one low point. And so to complete the wave, we would have to go a complete distance of 2 times the length of the chain in this case. So the wavelength of our wave is 2L. Remember, we've got a very general relationship between the wavelength and the frequency, lambda f equals v, or the frequency is the speed over lambda. So the frequency will be the speed over the wavelength. The wavelength is 2L. So the frequency of this wave, in terms of the length and the velocity of the wave, will be v over 2L. Now let's look at a wave, what I was trying to do before, where we've got something that looks like this. Now here, you can, I hope you can imagine, we've got 3 nodes. My hands, well, imagine that this hand is not moving. I have to kind of keep the wave going. This is really not working. This works a whole lot better if I have someone else holding the other end of the chain. But imagine, so we've got something like this. There we go, that's a little bit better. Where I've got a node at both ends where my hands are, and a node in the middle. So we've got 3 nodes and 2 antinodes. So 3 nodes here, here, and 2 antinodes here. Now in this case, the wavelength is just 1 complete length of the chain. So lambda is L. So the frequency, V over the wavelength, V over L. Then another one, I won't even try to do this one. Imagine that we've got 3 humps in the chain, like this. Now in this case, the wavelength, 1 maximum and 1 minimum, will be 2/3 the entire length of the chain. So lambda is 2/3 L. The frequency will be V over that, so 3V over 2L. And then say another one where the wavelength is 1/2 the length in this case, so lambda is 1/2 L. The frequency will be 2V over L. So those are the frequencies for these different standing waves. Now let me just rewrite this slightly. I'm going to stick a 1 in here. We know that's not going to change anything. I'm going to put a 2 and a 2. That doesn't change the value. Here, okay, to leave that alone, here, 2 over 1, I'm going to write that a little bit differently. I'm going to write that as 4 over 2. 4 over 2. So what do we notice? We've got a 2L in each denominator. This one is 1V, 2V, 3V, 4V. Well, that's very interesting. What do you think the next one would be? 5V over 2L. The next one, 6V over 2L. Exactly. If we call this frequency F1, the fundamental frequency, in other words, the frequency of the lowest mode of oscillation, the lowest way of oscillating, where we only have 1 hump. If we had anything shorter than this, we wouldn't, if we had anything longer than this, we wouldn't be able to have 2 nodes, right? If this were a longer wave, we wouldn't get those 2 nodes there. So this 1 hump with 2 nodes is the longest wavelength that we can have and still be able to clamp the 2 ends in place. And then what's this? Well, this is 2 times V over 2L. That V over 2L is our fundamental frequency. So this frequency is 2F1. Well, this is 3 times V over 2L. This is 3F1. This is 4F1. So this is the frequency of mode 2, frequency of mode 3, frequency of mode 4. We have a we see a very, very simple relationship that the frequency of the nth mode is just n times the frequency of the fundamental, the frequency of the lowest mode. It's a very, very interesting result, a very simple result for the frequencies of these types of waves. Let's take a look at one more. Let's imagine now, for this one we clamped both ends of the chain in place. Let's imagine that we could tie a string onto this end and hold that string very, very far away, so that this end could actually move up and down. It's attached to the string, but the string is still applying a tension to it. But because the string is being held very, very far away, there's nothing that will limit this end up and down. However, we'll clamp this end still in place. So this is still going to be a node. But this one, well, since it's free to move up and down, it's going to be an antinode. So what kind of waves can we have with a node at one end, but an antinode at the other end? Well, you might say, well, why couldn't we have a node at that end? Well, because anytime there's force acting on the end of the chain, it's going to want to move around. It's going to move up and down. It can't just stand still by itself unless something is clamping it in place. And if this end is free to move, it's going to be an antinode rather than a node. So what kind of arrangement do we have for standing waves in that case? Well, let's take a look. So with one fixed end and one free end, the longest wavelength that we can have is where we have one node at one end and an antinode at the other end. So what would the wavelength of this wave be? Well, from here, from equilibrium to maximum, to get a complete wave, we have to go equilibrium to maximum, and then the same distance L again to get back to equilibrium, and then the same distance L to get back to a minimum, and then the same distance L to get back to equilibrium again. So the wavelength is going to be 4 times the length of our chain, for example. So lambda is 4L. The frequency is then V over lambda, or V over 4L. What about the next one? Well, that would be when we had here's one node, one antinode. We have 2 nodes, and now 2 antinodes. So that would be the next one. So what's the wavelength in this case? Well, we go from equilibrium to maximum to equilibrium to minimum. Now we've got to get back to equilibrium again to make one complete wavelength. Let's imagine dividing this into 3 parts. So we've got equilibrium to maximum, maximum to equilibrium, equilibrium to minimum, minimum to equilibrium. So we need to add one more third. If that's a third, we need one more third. So a whole length plus a third is 4/3. So the wavelength of this one would be 4/3 times the length of the chain. The frequency would then be V over that, so that would be 3V over 4L. Okay, what about this one? The next one would be, well, we went from 2 nodes to 3 nodes, 2 antinodes to 3 antinodes, so this would be the next one. What's the wavelength in this case? Well, here we've got a complete wavelength right here. If we divide this up into 5 parts, 1, 2, 3, 4, 5, the wavelength would be 4 of those parts, so 4/5 of the length of the chain. So lambda is 4/5 L. The frequency V over that is 5V over 4L. What's the next one? Well, here we've got 1, 2, 3, 4, 4 nodes, 1, 2, 3, 4 antinodes. The wavelength would be from here to here. If we divide this up into 7 parts, 1, 2, 3, 4, 5, 6, 7. The wavelength would be 4/7 of the length of the chain, so lambda is 4/7 L, and the frequency is then V over that, which is 7V over 4L. Well, what we notice here, this is our fundamental frequency for the lowest mode. F1 is V over 4L. Well, this is 3 times V over 4L. So this is 3 times F1. This is 5 times V over 4L. This is 5 times F1 and 7 times F1. Well, what do you think the next one would be? 9 times F1, then 11, and 13 times F1, okay, etc., etc. We've got just the odd multiples of the fundamental frequency. So we say that this is F3, this is F5, this is F7, And again, we have Fn is equal to n times the fundamental, but we've only got the odd values for n. We don't have the even ones, just the odds. Very, very interesting result. Let's try one more. We did 2 fixed ends, 1 fixed end, 1 opened end. Well, what else can we try? How about 2 open ends? So let's look at a chain where, in this case, let's imagine that the 2 ends of our chain are tied to a string, and those strings go way off in that direction, and this end is way off in that direction. The strings, again, add tension to the ends of the chain, but the ends are free to move up and down. So what are we going to have? Well, we'll have antinodes at the 2 ends. So rather than 2 nodes, or 1 node, 1 antinode, we'll have 2 antinodes. So what kind of oscillations are we going to have in that case? Well, let's take a look. For 2 free ends, the longest wavelength we have is where both ends are antinodes, and then we've got a node in the middle. So what's the wavelength here? Well, going from maximum to equilibrium to minimum to equilibrium to maximum, we've got to go a whole nother length L to fit in an entire wave, and so the wavelength is 2 times the length of the chain. For this one, we've got antinode, 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 and 2 nodes. That makes 1 complete wavelength, so the wavelength is just the length of the chain. Here we've got 1, 2, 3, 4 nodes and 3 antinodes. You might notice that the number of nodes and antinodes has exactly reversed from our first situation where we had 2 fixed ends. So in this case, so from maximum to maximum, the wavelength would be 2/3 the length of the chain. So lambda is 2/3 L. And then we've got 1, 2, 3, 4, 5 antinodes, 1, 2, 3, 4 nodes, and the wavelength is here exactly half the length of the chain, so lambda is 1/2 L. So what frequencies do we get? We get V over 2L, we get V over L, we get 3V over 2L, and 2V over L. Again, let's write this as 1 times V, 2V over 2L, 3V over 2L, and rather than 2, let's write that as 4 over 2, so 4V over 2L. And again, what do we notice? Well, if this is our fundamental frequency, F1, V over 2L, we've got 2V over 2L, that is 2F1, 3V over 2L, that is 3F1, 4V over 2L, 4F1. So this is the 4th, 3rd, 2nd, 1, and what do we have? We have Fn equals n times the fundamental. So again, we have all of the multiples, 1, 2, 3, 4, 5, 6, 7, 8, etc., etc. So we end up with frequencies that correspond to the same frequencies that we had with 2 fixed ends. Okay, very, very interesting. What I'd like to do is show you what I think is a very, very interesting example of this, not with a chain, but with something else. I'll be right back.